In this lab, I investigated the motion of an object traveling in a straight line at what appeared to be constant velocity, and I compared the observed motion with the motion predicted by a model based on Newton's second law with no net force on the object. The motion that I observed was that of a peach traveling on a conveyor belt. My system consists of the peach, and everything else, including the conveyor belt, is part of the surroundings. I calibrated the length scale in Tracker using the size of the peach, which I measured to be 6.4 centimeters, and I chose as my axes so that the center of the peach was at the origin in the first frame that I evaluated, which was frame 3, and so that the positive x direction was traveling toward the right. I was then able to obtain the position of the peach every 0.33 seconds, starting with time t equals 0 and ending with time t equals 3.667 seconds. From Tracker, I made some observations of the initial conditions of the peach. The first time that I observed the position of the peach was at time t equals 0 seconds, and the peach begins at the position 000 meters. The next point that I observed the position of the peach is at 0.033 seconds, at which point the peach is at the position 0.00600 meters. I used this to approximate the initial velocity of the peach using the change in position divided by the change in time, and that came out to be 0.1800 meters per second. The computational model that I used to predict the motion of the peach is based on Newton's second law. Newton's second law states that the change in velocity of a system is equal to the net force acting on the system divided by the mass of the system times the change in time. For the peach traveling on the conveyor belt, it appears that the velocity is not changing. So the vector on the left-hand side, the change in velocity, would be equal to the 0 vector. So I made the assumption in my model that the net force acting on the peach is equal to the 0 vector. There are forces acting on the peach. For example, the force of gravity, as well as the force of the conveyor belt on the peach. I assumed, though, that when you add up all the forces acting on the peach, the net result is the 0 vector. To find the position of the peach, I used the formula here, which says that the final position is equal to the initial position plus the velocity times the change in time. Here you see the code that I used to predict the motion of the peach using my model. I found that the mass of the peach was 0.13 kilograms. Here I inserted the initial conditions that I found using my observations in Tracker. I then calculated the position of the peach every hundredth of a second, starting with the time t equals 0 seconds and continuing up to the time t equals 3.6675 seconds. I made the assumption that the net force acting on the peach was the 0 vector. Then I was able to calculate the velocity of the peach after each time step using Newton's second law, and I used that velocity to calculate the position of the peach. When we run this, we find that the motion of the object is like the peach in the positive x direction, and that the graph of the x coordinate versus time is very similar to the graph that we obtained in Tracker. As a final step, I plotted both the observed position of the peach and the position predicted by the model on the same graph. For the first second or so, the prediction is very close to the observed position. However, by the end, at about 3.5 seconds, they are off by about 4 centimeters. This discrepancy between the predicted position and the observed position is most likely due to inaccuracies in estimating the initial velocity of the peach. Note that the x-coordinate of the predicted position of the peach lies on a line through the origin with slope equal to the x-coordinate of the estimate of the initial velocity of the peach. If I had instead chosen the axes so that the positive x direction was to the left of the origin, then this graph would consist of lines through the origin with negative slope. In conclusion, the model seems to be a very good predictor of the position of the peach over a short interval of time, say 3/4 of a second, but over a longer period of time, inaccuracies in predicting the initial velocity of the peach make the model less accurate.